Okay, so this is the second part of that assignment. So you go back here, and you click on this one, and let's begin. So this is the first question. So you can pause to read it. I don't feel like reading it. So first, what we have to do is we're going to use this formula, right? So we're going to need two formulas for this. The first formula is FC is equal to mv squared over r, and the next one we're going to need is fs, or fg, or I'm not sure. We'll just put fg is equal to kx, and in this scenario fc is going to be equal to fg, which means that mv squared over r is going to be equal to kx. So, and we're going to be solving for velocity. So we're going to make this equal to velocity, which would mean that it would be v squared is equal to kxr over r, or not r, m, kxr over m. We can go a step further and just do this. So this is the formula we're going to use. So let's just begin putting things in. So k is going to be our 900 here, so we're going to put 900. Our x is going to be when at rest the spring, well no, it's going to be the stretched length minus the initial length, but you have to remember to put it from centimeters into meters. So we're going to do that now. And our r is going to be the radius of the circle, which is going to be 18 centimeters, because, or well, 0.18, because when the spring is stretched, it's going to be going from this point all the way to the end, so that's also the radius. We're going to divide all this by the m, which is the mass, which here it says 500 grams, but we have to use kilograms. So we're going to go to g to kg, and we're going to put in 500 grams, which is 0.5 kilograms. So the answer is going to be in two significant figures, so that's 5.8. So our next problem is two probes have been sent to orbit this Earth or planet, and probe 1 has a mass of m and orbits at a radius of 1, or r1, and the second one has 2m and orbits at a radius of 2r, the second one. So, which of the following correctly describes the relationship of the orbital speeds? So in this scenario, technically, probe 1's speed is greater than probe 2's speed, because it's closer to the planet, which means it would have to go faster to resist its gravity. So on a planet with no mass, on a third that of Earth, this rock falls. So what we're going to do first is we're going to do the equation. A equals the change in t over the change of v over change t. So A is going to be equal to our change in velocity, right? So our initial velocity is 10, or well, it's technically negative 10. That would be minus. So to get our change in velocity, we're going to go from negative 50 minus negative 10. We're going to divide that by the change in time. So that will be 9 seconds minus 0 seconds. So our acceleration is equal to negative 4.4 rpm. So next, what we're going to do is, well, that's technically our gravity. So we're going to put that as our planet's gravity. The Earth's gravity is negative 9.8 meters per second. So next we're going to use the universal gravitational law, or law of universal gravitation. And here's what we're going to do. We're going to put 9.8 on top of 4.44. Or we'll just need to do 4 for now. Oh, let's just do 4 that. And that's going to equal 2.207, which is now equal to r squared of our planet divided by 2r, well, not 2r, sorry, 1/3 r squared of Earth. Right. So now r squared of our planet is equal to the square root of 1/3 this 2.207 number and r squared of e, which means that 1/3 of 2.207 is equal to this number, which can be simplified by two significant figures to 0.86. Now this is our final question. To create artificial gravity in space, the thing rotates around a central axis as shown below. So basically, what we're going to do here is we're going to use our equation g equals v squared over r. So our g is 9.8 because it's orbiting space or Earth, and we're going to do v squared because we're trying to find v squared, or well, we're trying to find seconds, but first we need to find velocity. And we're going to put in our radius, which is 55, because that's what it says. So now we're going to form it so that we're solving for v, which is v squared is equal to whatever 9.8 times 9.8 times 55 is. And we're going to find the square root of it. So 9.8 times 55 is equal to that. The root of 9.8 times 55 is equal to 23.1 or 216, and that's now our velocity. But we still need to find seconds, and velocity is meters per second, or well, some distance over seconds. So we're going to do v is equal t, but we're going to change it to time, so that we solve for time, which is t equals d over v. Now we're going to do t equals 2 pi r over v, and we know our velocity, which is 23.216, and we know our radius, which is 55, which means that our answer is 14.88 or 15, since we're solving for two significant figures. Okay, so that's the second one. I'll see you in the third one.